As the question says, a block of mass m is kept on a rough horizontal surface. The coefficient of static friction between the block and the surface is mu. The block is to be pulled by applying a force to it. What minimum force it needed to slide the block? In which direction should this force act? Let us draw the diagram for this block. Then we are having here a block of mass m having a normal reaction N, an mg force in the downward direction, a frictional force of magnitude mu n in the left direction. Now, people often mistake by saying a force F equals to friction will be the minimum force. But note that is the force only for the when we have the restriction to apply only the horizontal force. Let us consider a case when the force is at an angle of theta. This theta can actually make the difference. It can reduce your efforts. So let this force be P. Now, since it is just to slide the block, there is no acceleration, that is acceleration equals to 0 for this block. So we can say that the normal reaction equals to mg. No, but this is not the case actually, because now we have not considered only the horizontal force, but we have considered the force at an angle theta. So obviously there will be a component of P in direction of n, that is the vertical direction. So we will be writing here as P sine theta plus normal reaction equals to mg. That is normal reaction equals to mg minus P sine theta. Marking it as equation number 1. Let us proceed to the horizontal direction, where we can say that frictional force, that is mu n, is equals to P cos theta. Let it be equation number 2. Now, putting the value of normal reaction from equation number 1 into equation number 2, we get mu into mg minus P sine theta equals to P cos theta, giving us P equals to mu mg by mu sine theta plus cos theta. Now, we can say that this force will be minimum when this whole will be minimum, and this will be minimum when this denominator is actually the maximum. So we need to maximize this denominator, which will be maximum only when the derivative with respect to theta of the denominator is 0. So, calculating it, we get the value of theta for that condition, that is mu sine theta plus cos theta equals to 0, giving us tan theta equals to mu. Now, putting it back into the equation of P, we can say that P equals to mu mg over 1 plus mu tan theta into sec theta. That is giving us mu mg over sec theta, which we can further write it as mu mg upon 1 plus tan square theta under root. That is mu mg over under root 1 plus mu square. So this is actually the minimum force that is to be applied in order to slide this box. Now here we can say that angle theta is tan tan inverse mu from here. So this much is the force and this much is the angle. That is, we have found out whole of the force vector.